Even though the United States has largely moved away from belching smokestacks and unfettered vehicle emissions, air quality is a significant problem for more than 126 million Americans. The Clean Air Act of 1970 was the first end-of-pipe regulation passed to control air quality and air pollution, and it has been amended since its passage. The Clean Air Act and the Clean Air Act amendments are the primary focus for this chapter. The learning outcomes for this chapter are: identify the major regulated air pollutants and recognize their sources and effects. Effects are human health and environmental. Explore major air quality problems and history of regulatory approaches taken to date. Recognize and explain the components of the Clean Air Act. Comprehend the evolution of the regulatory approach to air quality. Evaluate the effectiveness of air quality regulations. 6 major pollutants are targeted in the Clean Air Act of 1970. This group of pollutants was called the criteria pollutants. The term criteria pollutants derives from the National Ambient Air Quality Standards requirement that EPA must describe the characteristics and potential health and welfare effects of these pollutants. Sulfur dioxide, or SO2, is a corrosive gas. Natural sources of sulfur dioxide include volcanic eruptions, decay of organic matter, and ocean sea spray. More than half of the sulfur dioxide emissions are derived from human activities, especially combustion of fossil fuels for transportation, prior to the catalytic converters, and electricity generation. Respiratory damage and acid rain are 2 problems associated with sulfur dioxide. Nitric oxide and nitrogen dioxide are gases that contribute to acid rain, smog, climate change, and water deterioration and cause respiratory damage. Natural sources include lightning strikes and organic decay. At least half of the annual emissions are from human activities from motor vehicles, power plants, industrial emissions, waste disposal, residential wood combustion, fertilizers, and livestock. Carbon monoxide is a poisonous gas that leads to mental impairment, angina, impaired senses, and also accumulation of ozone, and it behaves as a greenhouse gas. Carbon monoxide results mostly from natural processes, but humans contribute a large amount, mostly via incomplete fuel combustion and motor vehicle exhaust. Other man-made sources include non-road vehicles and construction equipment, wood stoves, incinerators, and industrial processes. Tropospheric ozone is formed when nitrogen oxides and volatile organic compounds, or VOCs, react in the presence of sunlight. Ozone is the main component of smog. Since ozone is the byproduct of pollutants combining, the strategy for decreasing ozone is usually targeting the nitrogen oxides. Ozone has distinct effects on human health, which include eye irritation, nasal congestion, asthma, reduced lung function, possible damage to lung tissue, reduced resistance to infection. Ozone also influences ecosystems negatively, damage to plant tissues, inhibition of photosynthesis, and increased susceptibility to plant disease and drought. Particulates are solids and liquids that are suspended in the air, ranging in size from fine, smaller than 2.5 micrometers, to coarse, 2.5 to 10 micrometers. Gas transformation in the atmosphere and soil erosion form some particulates, but industrial development, combustion, and other dusty human activities increase the amount of particulates to a large degree. Negative health effects are amplified by particulate size as it decreases. Lighter particulates travel farther, both in the atmosphere and in our bodies. Most concerns are related to respiratory damage and visibility. However, it's important to note that in the last decade, there's been increased recognition of a direct link between particulate matter exposure and heart attacks. One plausible hypothesis is that the smallest particulates are able to pass into the blood. These particulates then act to encourage an increase in the formation of plaques. Lead, was added as a criteria pollutant in 1976 after the National Resource Defense Council won a Supreme Court case wherein they required the EPA to regulate lead given the requirements of the Clean Air Act and the known health effects of lead. NRDC v. Train. In the 1920s, a fuel additive, tetraethyl lead, was developed to boost the octane of gasoline and allow engines to run more smoothly. Prior to the implementation of the catalytic converter in cars in the 1970s, leaded gasoline was standard. Since catalytic converters do not work well with leaded gasoline, unleaded gas became the major product. Leaded emissions can also come from coal combustion, smelters, car battery plants, and the combustion of garbage that contains lead. Lead can also be present in the indoor environments with dust from old paint. The health effects of lead are severe and permanent, and especially potent for children. Lead can hinder mental development and performance. It can adversely affect kidney function and blood chemistry. Children are the most susceptible since they are more likely to ingest lead-contaminated soils and dusts, and young tissues are more sensitive to lead. Under the most recent 1990 Clean Air Act amendments, 188 airborne toxins are regulated. Of these 188, more than half are classified as known probable carcinogens. Most of what we do know about the toxicity of this group of pollutants comes from the studies of industrial workplaces, where these pollutants may be present in elevated concentration, and from animal studies. Some toxic pollutants causing great concern are benzene, primarily from chemical and plastic plants, vinyl chloride from similar sources as those for benzene, chlorinated dioxins from sources such as chemical processes and high-temperature burning of plastics in incinerators, asbestos, beryllium, mercury, arsenic, radionuclides, and coke oven emissions. These are the only toxic air pollutants that were regulated prior to the passage of the Clean Air Act amendments in 1990. Acid deposition is created when sulfur dioxide or nitrogen oxides react with sunlight and water vapor to form acids, which fall to the earth as acid deposition. Wet deposition may be snow or rain, and dry deposition may be in the form of dust or gases. Acid rain usually has a pH below 5, and it affects the eastern United States in particular due to the higher levels of industrial combustion. The amount of deposition and sensitivity of the recipient land determine the amount of damage caused. Areas farther to the northeast have granite or glacial soils, and they cannot buffer the greater amounts of acids that spread that direction through the atmosphere. Acid deposition causes soil leaching, increased erosion, harm to aquatic systems, building degradation, and public health issues. Depletion of the stratospheric ozone layer is problematic because it reduces our protection from solar radiation. Development of a hole in the ozone layer located above Antarctica has been tracked since the 1970s. This hole was primarily created by chlorofluorocarbons, or CFCs, which are compounds that persist in the atmosphere and break down ozone, O3, into oxygen, O2. The other depleting compounds are halons found in fire extinguishing foams. The 1987 United Nations Montreal Protocol aims to decrease ozone-depleting compounds and allow ozone layer recovery by about 2050. Greenhouse gases are those that exist in the outer layer of our atmosphere. They let visible light from the sun pass through, and when energy is radiated off the Earth's surface, some of it escapes into space, but greenhouse gases reflect and retain some of the energy as heat. This process, called the greenhouse effect, is essential for life on Earth because it allows the surface to be warm enough. However, release of more greenhouse gases leads to more warming, which has uncertain consequences. Some of these gases are carbon dioxide, methane, nitrous oxide, and fluorinated gases. Increased emissions of greenhouse gases since the Industrial Revolution is strongly correlated with temperature increases. The Intergovernmental Panel on Climate Change, IPCC, is the international group of scientists commissioned by the UN. The IPCC assesses the scientific, technical, and socioeconomic information relevant for the understanding of the risk of human-induced climate change. The IPCC has issued 5 assessment reports from 1990 to 2014. Sea levels could rise due to warm water expansion and the melting of ice at the planet's poles, an especially important issue for island and coastal inhabitants. Vegetation growth appears to have already responded to changing climate zones. Precipitation and temperature effects on agriculture have the potential to affect our ability to feed a growing world population. Additionally, the spread of certain diseases may intensify and expand their ranges to new regions depending on vectors and pathogens affected by climate change. Global warming is still perhaps one of the most controversial international issues today. Although most countries admit the global warming is occurring, nations frequently disagree about what to do to ameliorate the situation. The Kyoto Protocol was an attempt by the global community to reduce greenhouse gas emissions by the early 2012 by an average of 5.2% below 1990 levels, and consequently reverse the trend of warming. However, the enforcement of the treaty depended on the ratification of many developed countries, including the United States and Russia. In 2001, President Bush took a major step toward encouraging the demise of the Kyoto Protocol by going back on his campaign pledge and saying that the United States was not going to be a party to the Kyoto Protocol. By pulling out of negotiations over the treaty, the United States made it extremely difficult for the treaty to become effective because the protocol had to be ratified by 55 industrial nations responsible for at least 55% of the carbon dioxide emissions. The United States accounts for 35% of global emissions. In 2004, Russia provided the key signature to the treaty. The Kyoto Protocol went into effect in February of 2006. As of 2010, 184 countries have ratified the treaty, representing nearly 62% of the global emissions covered in the treaty. The 9 years between the drafting of the treaty and its going into effect illustrates the difficulty for forging international environmental treaties. In part, the Kyoto Protocol's slow ratification process is due to the tragedy of commons or the free rider problem. All countries will benefit from the reduction of carbon dioxide emissions, yet if some countries, including the United States, are unwilling to cooperate, all may suffer in the end. Indoor air pollution occurs when airborne toxins, irritants, and other air pollutants become trapped inside buildings because of inadequate ventilation throughout the building. The EPA estimates that as many as 30% of new remodeled buildings have indoor air quality problems. Poorly ventilated buildings trap airborne pathogens such as bacteria, fungi, and viruses. They also trap radioactive gases such as radon, a wide range of inorganic compounds such as lead and mercury, and organic compounds such as formaldehyde and chloroform. Many of these harmful pollutants are caused by indoor smoking, the use of wood stoves and space heaters, chemicals on furniture furnishings, and the use of cleaning solvents, wood finishing products, and air fresheners. In the short run, these pollutants can cause sick building syndrome, which is associated with runny noses, headaches, eye, nose, and throat irritations, fatigue, lethargy, irritableness, dizziness, and nausea. In the long run, they may lead to the impairment of nervous systems and cancer. Indoor pollutants are a special problem for the old and young who spend more than an average amount of time indoors. The average person in the United States still spends 90% of his or her time indoors, consequently exposing himself or herself to indoor pollutants. While the Clean Air Act of 1970 is the primary piece of legislation that regulates air quality in the United States, it has not been the only attempt to control air quality. In fact, the first of such laws were passed in the 1880s as local ordinances in northern United States cities where smokestacks created significant air pollution. The Air Pollution Control Act of 1955 primarily functioned to support federal research of air pollution control. The Motor Vehicle Act of 1960 was a recognition that automobiles contribute to air quality problems, and it authorized research into the pollution effects of motor vehicles. The first National Air Quality Act was the Clean Air Act of 1963. This act, however, did not mandate any reduction of pollution and consequently was ineffective as a method for pollution control. In addition, the act did not define air pollution, stating only that the statute's purpose was to prevent and control air pollution. This is difficult to control a problem when the problem is not well defined or understood. The Motor Vehicle Air Pollution Control Act of 1965 allowed the Secretary of the Department of Health, Education, and Welfare, HEW, to establish standards for new vehicles or engines with considerations of economic and technological feasibility. The act was not especially effective due to these considerations. The 1967 Air Quality Act was actually a set of amendments to the 1963 Clean Air Act. It outlined federal air pollution control by creating procedures for state air quality standards, defined 10 atmospheric regions of pollutant concentrations, and defined regions where air quality could be effectively regulated. The state air quality standards are called ambient standards, meaning that they were for a representatively sampled area. They define maximum allowable concentrations of air pollutants, and the HEW could require inadequate standards to meet adequate levels. Once these standards were established, state implementation plans outlined how states could meet the standards of the state as part of its respective regions. Under this act, the federal standards were preemptive, that is, stricter limits on automobile emissions were not allowed. Despite the gains made from a policy perspective, this act was not very effective. The potential reasons for the failure of its effectiveness include the emphasis on air quality regions, which cut across established state and jurisdictional lines. Consequently, it was difficult to obtain agreement on standards and implementation plans. There were also numerous delays in implementing the steps of the act, such as delays by federal government in designating regions and issuing criteria documents. States delayed adoption of plans because of a lack of personnel, information, and political will. Another reason for the Act's ineffectiveness was that, like previous air quality regulations, this Act failed to define air pollution. Reductions in pollution were less likely because the act imposed economic and technological feasibility conditions on the standards. The legislation left extensive discretion to the states. The Clean Air Act of 1970 and the subsequent amendments in 1977 and 1990 are the statutory basis of air quality regulation today. Leading up to the programs implemented under the Clean Air Act, there were several factors that underpin the strategic approaches employed. Congress was highly dissatisfied with the lack of progress in the area of air quality. State governments responsible for enforcement of programs were perceived as weak and vulnerable to industry blackmail. Furthermore, there was variability among states in the strictness of the regulations, resulting in potential disadvantages among competing businesses. The Department of Health, Education, and Welfare was perceived as lacking zeal. Thus, the Act addressed these concerns. It created partnership between state and federal governments. Under the Act, states are responsible for monitoring, controlling, and preventing pollution. EPA is responsible for establishing the standards the states must enforce, conducting research, and providing financial and technical assistance to the states. When necessary, EPA will assist states in implementation and enforcement of regulations. It is essential to understand the various strategies embedded within the Clean Air Act. National Ambient Air Quality Standards, NAAQS, sometimes pronounced NAAQS, New Source Performance Standards, NSPS, No Significant Deterioration, NSD, New Source Review, Mobile Source Emission Standards, Hazardous Air Toxin Standards. National Ambient Air Quality Standards, NAAQS. The Clean Air Act required the EPA to identify pollutants that have an adverse impact on human health and welfare, and to establish ambient air quality standards for these pollutants. Ambient air quality refers to the quality of the air representatively sampled from an area. EPA divided the U.S. into 247 air quality regions. Each region has common pollution sources and characteristic weather. At first, EPA set standards for carbon monoxide, sulfur dioxide, hydrocarbons, total suspended particulates, nitrogen oxide, and ozone. The hydrocarbon standard was subsequently dropped, and lead was added after the Natural Resource Defense Council sued Russell Train to require him to set it as a criteria pollutant. EPA prepares a criteria document for each pollutant. It contains the scientific evidence of the negative health effects of each pollutant and the methods for controlling its emission. Primary standards are necessary to protect human health. Human health is interpreted to include the health of the most sensitive individuals, such as children and the elderly. Some pollutants have primary standards for both long-term and annual average and short-term 24 hours or less. For example, nitrogen dioxide and particulates. Secondary standards are sufficient to protect public welfare. Public welfare includes visibility, plant life, animal life, and buildings. Every 5 years, the evidence for the standards must be reviewed and the new data analyzed to ensure that the standards are still valid. For example, the EPA again adopted new rules that reflect changes in data and available technology for fine particulate matter. Anytime new standards are set, they are likely to be challenged in court by affected industries. State implementation plans, SIPs, S-I-P-S. You will recall that the legislature enacts the Clean Air Act or a set of amendments to it. The EPA promulgates regulations or other requirements to the law to fulfill the act using informal rulemaking unless otherwise indicated within the legislation or the enabling legislation of the agency. So in the case of NAAQS, the EPA sets the standards and meets the requirements of the Administrative Procedures Act and the plan within the Clean Air Act. Once the standards are set, the states are required to develop implementation plans, SIPs, to meet the NAAQS within 3 years for the respective air quality regions within the state. A SIP, or a state implementation plan, is submitted for each criteria pollutant within 9 months of the NAAQS being received. There can be an 18-month extension. The EPA approves or rejects the SIP within 4 months. If an inadequate or incomplete state implementation plan is submitted, the EPA must promulgate a plan or part thereof for the state. Or the EPA can cut off funding for highways within the state or ban construction in non-attainment areas. As noted, a state implementation plan is to provide for attainment of the NAAQS within 3 years of the date of its promulgation. A 2-year extension upon request of the governor is possible if the technology for certain sources is unavailable. Problem of non-attainment. An air quality region is defined as not in compliance when the second highest 1-hour average concentration per day exceeds the NAAQS. The most success in meeting the National Ambient Air Quality Standards has been with lead and nitrogen oxides, or NOx. The most troubling pollutant has been ozone. To combat the ozone non-attainment, the 1990 amendments divided air regions with non-attainment into classes: marginal, moderate, serious, severe, and extreme. Based on these categories, they were given 3 to 20 years to meet compliance with intermediate goals for all the classes above marginal. Automobile Inspection and Maintenance Program. The 1990 amendments also set special standards for urban areas with more than 200,000 people and moderate, serious, severe, or extreme air pollution. These areas must have vehicle inspection and maintenance programs with emissions testing and enforcement via registration processes. Permit Program. In 1990, the Clean Air Act amendments require all large and most small sources of air pollution to get a 5-year permit. These permits must list limits for all pollutants the entity will emit. Thus, the permit allows the entity to emit pollutants so long as it is in compliance with the permit. Permits are issued by state and local permitting authorities. All pollution control requirements are now streamlined into one operating permit. Permits may be challenged by public hearings prior to issuance. However, once issued, it is a shield for the entity to emit so long as it meets the requirements of the permit. New Source Performance Standards, Section 111 of the Clean Air Act authorizes the EPA to develop technology-based standards which apply to specific categories of stationary sources. These standards are referred to as New Source Performance Standards, NSPS. The New Source Performance Standards apply to new, modified, and reconstructed affected facilities in specific source categories such as manufacturers of glass, cement, rubber tires, and wool fiberglass. As of 2013, there are approximately 90 NSPSs. The NSPS, New Source Performance Standards, are developed and implemented by EPA and are delegated to the states. However, even when delegated to the states, EPA retains authority to implement and enforce the NSPS. New Source Review, NSR, was formed by the 1977 Clean Air Act amendments. It requires a stationary source of pollution that has major modifications that significantly increase emissions to meet the stricter standards that the new sources of pollution must meet. Major modifications are those that increase amounts of any air pollutant unless they are part of a routine maintenance, repair, and replacement. Electricity plants, in particular, challenged NSR requirements by calling all improvements to old plants routine maintenance. Under NSR, new sources must also obtain permits. The stricter standards under NSR require best available control technology, BACT. It was originally hoped that older plants would be retired and new plants would meet higher standards. Instead, there's been a tendency to patch up older facilities. In fact, there was simply a lack of enforcement for power plants to comply with NSR requirements until the Clinton administration. Later, during the George W. Bush administration in 2003, the EPA relaxed NSR rules quite a bit as they acted to clarify interpretation of the law. For example, routine maintenance has been defined to allow maintenance upgrades and expansions to occur without requiring new pollution controls, so long as the cost of the changes do not exceed 20% of the cost of the entire process unit, an ambiguous term itself. Under this new rule, major utility plant changes that cost millions of dollars and increase pollution by thousands of tons can be defined as routine maintenance, and thus be exempt of the Clean Air Act protections. Oil and natural gas air pollution standards issued under New Source Review. In 2012, the EPA established the first federal air standards for natural gas wells, fracking, as well as other sources of pollution from the oil and gas industry. These standards require reduced emissions completion or green completion practices, meaning that natural gas that escapes into the air is captured. Revenues from selling this gas will pay for the upgrades necessary to capture it. At full implementation, the goal is to reduce VOC emissions by 95% and reduce air toxics and benzene, methane added in 2015. Until then, there will be flaring required. Additional regulations issued for natural gas processing plants, storage tanks, transmission lines will reduce emissions of air toxics, for example, benzene. Greenhouse gases regulated under New Source Review. Starting in 2011, new construction projects that emit at least 100,000 tons of greenhouse gases and existing facilities that increase their emissions by at least 75,000 tons per year, even if they do not exceed thresholds for other pollutants, are required to include greenhouse gas emissions in their New Source Review permit. New and upgraded facilities subject to the requirements will be required to install the best available control technology to control their greenhouse emissions. Carbon pollution standard for new power plants. In 2012, the EPA set the first limit on carbon pollution from all new power plants. The new rule holds all power plants, regardless of their source of fuel, to the same standard. The rules will limit emissions from new power plants to 1,000 pounds of carbon dioxide per megawatt hour, about the level for a modern natural gas plant. Prevention of significant deterioration. When a permit is issued for a new or majorly modified source of pollution, it must follow the Prevention of Significant Deterioration (PSD) program. Many areas are cleaner than the NAAQS, or the National Ambient Air Quality Standards. How do you manage development such that there is not a slow deterioration of all environment? To do this, they've implemented a 3-class system. Class 1 most pristine, minimal increase is allowed. Class 2 is a moderate degradation is allowed to remain significantly cleaner than the national ambient air quality standards. Class 3 allowed slightly more deterioration from new sources, and in some cases they are allowed to degrade the level of secondary standards. Class 3 are allowed slightly more deterioration from new sources, and in some cases, they're allowed to degrade to the level of secondary standards. The analysis includes an assessment of existing air quality in the region where the source will be located and predictions using disbursement modeling of ambient concentrations that will result from the applicant's proposed project and further growth associated with the project. A permit will not be granted if the projected emissions from the new source or the modification would adversely affect the air quality in a Class 1 region, areas of special national and regional, natural, scenic, recreational, or historic value where the air quality significantly exceeds the national ambient air quality standards and for which the PSD regulations provide special protection. A permit may also be denied if its granting would cause the air quality of a region that met the NAAQS to fall into non-attainment. Mobile source performance standards aim to decrease emissions of hydrocarbons, carbon monoxide, and NOx. Federal Motor Vehicle Control Program under the Federal Motor Vehicle Control Program, CARS must meet standards for fuel evaporation, carbon monoxide, nitrogen oxide, VOCs, and particulates as set up by the EPA. A major success of this program was the reduction of lead content in the gasoline. In 1990, the Clean Air Act gas reformulation, the 1990 Clean Air Act amendments required gasoline reformulations to meet tailpipe emission standards. In 1991, the EPA proposed cleaner oxygenated gasoline sales in the cities with the worst pollution. By 1995, gas had to help the goal of reduced hydrocarbons. In 1999, Compliance Assurance Program, the 1998 Compliance Assurance shifted focus from new vehicles to those already in use. Despite many complaints over program drawbacks, such as reduced mileage, minor health problems from reformulated fuels, and costs, it was an effective way to reduce pollution. However, health concerns over one of the oxygenates, MTBE, used in the reformulated gasoline led to decreased use of MTBE. Corporate average fuel economy. Congress has also ruled on the amount of fuel that can be used. This is done through the Corporate Average Fuel Economy, or CAFE standards, which measure year average fuel economies for passenger cars and light trucks. Standards have most recently been updated to require a CAFE standard of 35.5 miles per gallon by 2016 and 54.5 miles per gallon by 2025. The EPA was also given authority in 2007 to regulate carbon dioxide and other greenhouse gases. The 1990 Clean Air Act amendments. Continuing air quality problems led to the 1990 Clean Air Act amendments. Programs to cover acid rain and air toxics, as well as a process to help areas in non-attainment. 1990 Air Toxics Program. Toxic or hazardous air quality pollutants can cause health and environmental damage even at low concentrations, and they are regulated by the 1990 Air Toxics Program. Industrial plants had to significantly reduce emissions of 188 pollutants deemed hazardous by the EPA. There are strict deadlines associated with reductions. One category of toxics is major sources. They can or do emit 10 tons per year of one toxic air pollutant or 25 tons of combined toxics. Major sources must use maximum achievable control technology, MACT, rather than meeting emissions limits. MACT is met by the best emissions control that a facility in the same category or subcategory uses. Area versus facility sources may have to meet generally achievable control technologies, GACT, or management practices. The EPA also had to finish an accident prevention program by 1992 requiring risk management plans, RMPS, for industry with information available to the public and the EPA. Mercury emissions. Mercury travels through and accumulates in biotic systems. Exposure to mercury can have neurological effects, especially on children. In 2001, mercury was regulated under the Clean Air Toxics Program, which meant that MACT standards had to be met by utility plants. In 2005, the Clean Air Mercury Rule removed power plants as sources of hazardous pollution and did not require mercury emission reductions at all. This mercury rule was struck down in 2008 by the Federal Court of Appeals in New Jersey versus EPA as a violation of the Clean Air Act. In 2011, the Mercury and Air Toxic Standards, MATS, MATS, established air pollution controls for mercury and other toxics. Acid Rain Control Program. The other main accomplishment of the 1990 Clean Air Act amendments was the Acid Rain Control Program. Sulfur dioxide emission limits were carried out in two phases using allowances in the cap and trade program. Violators get the next year's allowances reduced and may face fines and civil or criminal penalties. Success of the sulfur dioxide program led to a similar NOx program for industrial boilers. Emissions reductions were a success in the acid rain programs. Enforcement of the 1990 amendments. State implementation and enforcement determined the success of the Clean Air Act and its amendments. State implementation plans were established slowly, but enforcement has improved because criminal violations have been upped to the felony category. Civil penalties are provided for cases of firms knowingly violating sections of the Act. The EPA is also allowed to reward citizens who bring a report that leads to criminal or civil penalties. Citizens may also sue and enforce compliance with standards or force the EPA to enforce.